Hello everyone, we are Keylime Group and welcome to our final project demo. We are a group of 3 with Yilin Ma, Chencheng Geng, and I am Feng Qiqiao. Our mentor is Purvi Mohan. Since our project is to add improvements to Keylime web app service and build new front-end UI for Keylime, so before diving into details of what we have done and achieved, I want to first give a brief background of Keylime to help you better understanding of our project. So here's a high-level view of what Keylime is. Keylime is an open-source project, provides remote attestation based on hardware-rooted trust by means of a trust platform module. Keylime can provide remote attestation both for boot and runtime. After establishing trust to nodes, we can send encrypted payloads to agents. Besides, Keylime provides revocation framework to manage failed nodes. Next, let's see Keylime's main component. On the left-hand side is the node we wish to measure for trust. To the right-hand side is the management network, where we run Keylime's core services, including verifier, registrar, and tenant web app. Keylime agent communicate with TPM and send back quote to verifier. Then verifier checks node's integrity. Registrar is more like a database to store information of registered nodes, and a certificate to store public keys. Keylime provides both CLI and GUI management tool, which is tenant and web app service. Our project main focus is to improve current Keylime web app service and build a new front-end UI. Originally, there are quite a few problems regarding web app service. Its scalability is poor. It has hard time even scale up to support 20 agent nodes. Besides, frontend was first built as a demo prototype a few years ago and lacked maintenance. We cannot run web app frontend unless doing some modifications to source code since it is quite buggy. So basically, this is the background of our project. Now let's move on to project goals. Our project mainly focused on the following 2 parts. First, we did performance analysis of Keylime on a large group of nodes and add improvements to Keylime web app service. This part include deploying Keylime services on a 100+ node MOC. We also tested out its scalability and analyzed its bottleneck. Besides, we automated the Keylime deployment as well as virtual machine management. Second, we built a new front-end UI, allowing cloud administrators easily get an overview of the system as well as specific single node status. The web app should collect information without affecting attestation itself. Basically, for the first half part of the semester, we focused on deployment of Keylime on local machine as well as MOC, and we carried out detailed performance analysis. For the second half of the semester, we focused on adding improvements to Keylime web app service as well as building a new front-end user interface. This is all for my part. Next, I will pass to Yilin, who will talk about our key decisions as well as deployment and visualization architecture.
Hello everyone, this is Yilin, and in this part I will talk about 3 important decisions in our project. In the beginning, we had to find out a systematic way to deploy Keylime services in our cluster, and there are 2 common solutions, containerization and virtualization. If we want to run Keylime in containers, we need to containerize the services and also use a orchestration tool like Kubernetes or Docker Swarm to run these containers in the virtual machines. In this case, the size of these virtual machines can be the same. Each of them will have multiple containers running on it. And the other way is to deploy the services to virtual machines directly. To fully utilize our computational resource, the heavy service will be running on a big virtual machines, well, the other lightweight, the many other lightweight services like the Keylime agent will be deployed to a lot of tiny virtual machines. Although at first glance the containerization seems work, it needs some extra configurations. One big thing is that to detect if a file has been modified, Keylime agent must enable Linux integrity measurement architecture, aka Linux IMA. Other people did some research and came up with some novel ideas on how to measure the integrity of containers in 2019, but it's too difficult for us to do. So we gave up on this containerization approach and decided to go with virtual machines directly. As for the virtualization approach, it's necessary to automate the deployment and operations over 100 VMs, right? Using a shell script is not a good idea because we still need to SSH into the virtual machines and handle the errors manually. Instead, we use Ansible to install, uninstall, and run and stop services in our cluster. The second decision is about performance tuning. During our test, we figured out a trade-off between how quickly the user can tell something is going wrong and how much resource will be used by the visualization web app. In our experiment, when the throughput between the web app and the verifier is around 5 requests per second, the verifier CPU usage doesn't increase by a noticeable margin, and the maximum latency is less than 800 milliseconds, which is pretty acceptable. And when the throughput reaches 12.5 requests per second, the latency remains the same, but we can see some spikes in the CPU usage. At peaks, the verifier takes 85% of CPU time on 6 vCPUs. And this peak will last around 5 seconds every 20 seconds. When the throughput is 20 requests per second or even higher, the backend services get overloaded by the visualization web app, real quick, and the latency even becomes higher than 1 minute. To make sure that the verifier and other important services are not dominated by visualization, we decided to go with a conservative tuning, where the visualization web app uses the minimum resource it needs. We also make the throughput configurable just in case if we want to get the feedback quicker. So in our default configuration, the front end retrieves 10 agents every 2 seconds. As a result, if the user has 200 agents to watch, all of the state will be updated in 40 seconds. And the last decision is about the user interface. On the left, we had a really interactive graph which has some fancy animations, but as you can see, when there are a lot of agents in the system, the section on the outer layer becomes very small, becomes too small to work with. So after the discussion with Keylime team, we finally implemented a traditional pie chart on the right to give an overview of the system, so the users can know how many agents have been validated and how many failed to do that. Let's go through Keylime architecture. In this part, I will first briefly explain the deployment architecture, and then I will focus on the visualization architecture in Keylime. So in our cluster, there is an Ansible server, which is in charge of the entire system. It has a playbook for each service, and the service playbooks are the YAML files down below. The service playbook can be used to install and uninstall dependencies and start and stop these services so that we can always have a clean environment. And this environment is always ready for a new Keylime version, which is going to save a lot of time for us, basically in this project. And before we get into the details of Keylime visualization, let's see how a normal visualization workflow looks. Mostly it starts from an analytics database, and you can run a query, get a bunch of tuples out of it, and then the tuples will be processed into a result. Finally, the result will be rendered. This simple linear architecture works because someone else has already collect everything you want and store it in a database. So later you just need to go to one place to find everything you want. Well, in Keylime, the registrar manages the registration and the verifier validates the agent and maintain the state. In other words, the registrar only has a list of registered agents ID, and it doesn't know the state at all. Well, by contrast, the verifier doesn't care about the registration. It only has some states in the database, in its database, and some metadata as well. So we have two places to look at, right? The verifier and the registrar, instead of a single one. The architecture looks like this diagram. The agents are updated in batches rather than all at once because we don't want to increase the interval when there are more and more agents in the system. In each interval, the front end is going to ask the new state of one batch. It goes like, hey, visualization web app, give me the latest status in this batch. And the visualization web app is going to send a call to the registrar to get the agent UUIDs within this batch. And for each UUID, it will make another API call to the verifier to get the latest status back. And finally, the new state, the list of new states will be sent back to the browser and will be rendered there as well. This is how Keylime collects the agent state, collect the latest agent state. Unfortunately, we cannot change the we cannot make some big change in the verifier and registrar API. All we can do is understand how it works clearly, and get rid of some problems. For example, like remove duplicated API calls in it to make sure that the traffic between services is minimized. That's pretty much all about my presentation, and my teammate Chen Cheng is going to do the rest of the presentation.
Next, I will talk about what we accomplished in this project. First, we have submitted 3 pull requests to Keylime repository. The first one is adding support for Keylime web app service to read intervals from Keylime config file, and this has been merged. The second one is about removing duplicated calls to verifier, and this PR is under review now. The third one is about a new web app GUI. We proposed a new GUI design to Keylime web app. This pull request is under review by the team, and based on the comments, we will try to get it merged in a week. So next, I will do a demonstration on our new web app GUI. But before that, I put a screenshot of old version GUI here to make a comparison. The old version GUI did not provide an overview of all the agents' status, and it did not have pagination, which means if you have hundreds or thousands of agents, they are displayed in one column, and you have to keep scrolling down to check them. So here is a demonstration on the new GUI that we proposed. In the left-hand side, there's a pie chart which displays the proportion of each agent status. This is kind of like an overview of all the agents. And as you can see here, there are 85 agents, which is 76.6% of all agents are registered now. 2 get quote and 20 failed. When you click on a specific category in this right-hand side, you can see a table which displays all the agents belong to this category. We add pagination here, so there are only 10 agents in one page. You can click on the Prev and Next button to browse all of them. And if you click on each agent, you can see detailed information of it, like this. You can also check other categories like terminated and registered. And there are 9 pages here. And here we try to update one failed agent in the backend. And this agent has been validated now. Let's try to update another one. And you can see it has been updated too. And you can go to this pie chart and see that the red proportion becomes smaller and the green proportion becomes larger. We can go to specific categories to check the updates. Next part is limitations of our project. One limitation is the API design of Keylime. Current Keylime APIs only allow that the front end keeps sending API calls to fetch agents information from backend, even if there are no updates. In the future, when some agents are updated, we want backend to push data to front end, which is more efficient. Another limitation is about the HTML rendering of the web app. Now Keylime web app is using brutal way to render web page, which makes it difficult for developers to read and write code. In the future, this can be improved by using Tornado template or other front-end frameworks. The last part is the burn-on chart. In this project, we encountered different problems during deployment, analysis, and front-end development. At first, we had a hard time deploying Keylime. We tried containers, we tried virtual machines, we tried different versions of Linux. Then we had to learn tools like Ansible and the OpenStack command line tool to automate deployment and management. At last, we spent some time on front end and proposed a new GUI. That's all for our final presentation, and thank you.